Today I'm gonna cover the nomenclature of ionic compounds. When a metal reacts with a non-metal, it forms ionic compound, right? So first we need to classify the elements as metals, non-metals or metalloids. For naming purpose, we will consider metalloids as non-metals. Ionic compound, it consists of metal and non-metals or ammonium and non-metals. So it has cation and anion. Cation positive charge means loss of electron, anion negative charge mean gain of electron. Cation, it can have constant charge, meaning all the metals beside transition metal they have constant charge, meaning single charge. It can be ammonium as well, or it can have variable charge, meaning transition metal it has multiple charge except zinc, cadmium and silver. For example, iron, okay, so it can have charge 2 plus or 3 plus. So cation, it can be constant charge, ammonium, or it can have a variable charge. Now anion, it can be monoatomic, meaning single atom, for example chlorine, or it can be polyatomic, for example ClO3. Okay, so chlorine is one atom, oxygen is another atom. So it is, if it is two or more than two atoms, then it is called polyatomic. Now what if the cation is a constant charge and anion is monoatomic? All the metals from group 1 and group 2 as well as aluminium and 3 transition metal that I mentioned earlier, all of them they have constant charge. Okay, so we will write the cation element name, whole name, and for anion we will write the base name and we will add IDE at the end. Okay, for example KCl, we will write the whole name for K, which is potassium, and Cl is chlorine, we will write as CHLORIDE, chloride, IDE at the end. Okay, so MgO, Mg is magnesium oxide, IDE. This one zinc, N is nitrogen, we will write as nitride. Okay, so zinc is a transition metal but it has a constant charge. Now how to write the chemical formula if the name is given? Okay, magnesium, we know magnesium has 2 plus charge. Oxide is oxygen and it has 2 minus charge. We can do crisscross. Mg, this 2 comes here, this 2 goes here. Because this is ionic compound, we will write the empirical formula. We will not write as Mg2O2, rather we will write as MgO. There is an exception for peroxide. For example, Na2O2 is sodium peroxide. Okay, so we will not write these as NaO. So this is an exception for peroxide. Another example, aluminium phosphide. Aluminium has 3 plus charge and phosphide, it comes from phosphorus and it has 3 minus charge. Again, both 3 it will cancel out, so it will be only Alp. Now coming back to the nomenclature, what if the cation has a variable charge or multiple charge or transition metal beside zinc, cadmium and silver, and anion is still monoatomic? For cation, we will write the whole name. Then we have to mention the charge inside the parenthesis. Okay, for transition metal, they have not only single charge, they have multiple charge. So we have to mention the charge inside the parenthesis. And for it is still monoatomic, so base name of an element and add IDE at the end. For example, FeO2. Fe is iron because it is transition metal. There is charge inside the parenthesis. Okay, how do we know this is 4? Let's find out. Here we need to know the charge of the anion. Okay, there are two oxygens, okay, and we know the charge, we must know the charge of the oxygen, okay, so it has -2 charge, and because there are two oxygen, we will multiply by 2, so the overall or the total anion charge is -4, okay. Because the compound has to be neutral, iron must have +4 charge, that's why this 4 goes here. Another example, CO2O3. We know CO is cobalt, we know O is oxygen, so cobalt oxide. But what's the charge of the cobalt? Let's find out. Oxygen, -2 charge, and there are 3 oxygens, so -6 is the overall anion charge. Now cobalt, there should be +6 charge to make this compound neutral, but there are already 2 cobalt, okay, so we will divide this charge by 2 and it will give me +3. So the name is cobalt 3 oxide, okay. So we can double check cobalt, if the charge is 3 + 3 times 2 cobalt, so it gives +6, and oxygen is -6, okay. That is how we can do it. Now here's the another condition. What if the cations, it can be constant charge, it can be ammonium, or it can have multiple charge as well. What if the anion is polyatomic, okay. For polyatomic, we will write the name. Here comes its. What are its? I'm gonna explain you later. So you have to determine how many oxygen atoms the 8 ions have, okay, and you need to know what charges the 8 ions have. For example, if it is SO4 charge 2-, this is polyatomic, okay. The name of this is SULFATE. Here comes 8. Now if I decrease 1 oxygen from this sulfate anion, it is going to be SO3 2-, and remember this charge will never change. This is going to be SULFITE, ite, okay. For example, Na2SO4, name will be sodium sulfate, okay, sulfate, ATE. Na2SO3, sodium sulfite, ITE. There is a hint on how to find the number of oxygen and the charge on polyatomic ions, okay. So here's the periodic table. All the polyatomic ions towards the corner, okay. So if you see, it has 3 number of oxygens on all of them. In all the middle one, the number of oxygen is 4. And what about the charge? We will start from the corner, okay. For example, here ClO4, it has -1 charge, -2, -3, -4. Same here, -1, -2, -3, -1, -2. Here the first one, -1. Because it is oxygen, we will stop and start again, -1, -2, -3. That is how we can find the number of oxygen in the charge, okay. This FO3 minus is fluorite, okay. If I decrease 1 oxygen, FO2 charge is same, remember it is going to be fluorite, okay. There is a little bit more for the halogen, okay. So all these are halogens, okay. ClO3 is chlorate, ATE. 1 less oxygen, ClO2, charge is same, okay, chlorite, ITE. Now if I add 1 more oxygen on chlorate, which is going to be ClO4, 4 minus, it is perchlorate. Okay, so this per comes here, and if I reduce one more oxygen from chloride is ClO2 minus, so ClO, this is going to be hypochlorite. Okay, and this is only for the halogen, remember. Okay, only for the halogens. These are some polyatomic anions that you have to memorize. Okay, I don't have any hints for that. For example, let's take Cn. If it is NaCN, sodium cyanide. Okay, so you have to memorize these anions. Now you can try out these examples. You can pause the video and try it on your own. Here's the answer. Okay, you can check your answer. Now try to find the formula for this compound. Again, you can pause the video while working. Here's the answer. Alright, good luck.